Even before the Great Offensive in the West got underway, the list of jobs being handed to the Bf-110 heavy fighter had grown considerably. It was now expected to do a lot more than simply hunt enemy aircraft. Combat experience quickly made it clear that the design needed serious work. That led to a new production variant, the Bf-110C3. Its most obvious visual difference from earlier models was the removal of the bulky fairings that had covered the MGFF cannon. Then came the next step forward, the C4. That version was the first to give the pilot and gunner any armor protection at all, even if it was fairly minimal. Of course, adding that armor came at a cost. The standard takeoff weight went up by nearly 496 pounds. But the weight climbed even faster when someone decided to turn this fighter into a J-bow, the German shorthand for fighter-bomber. To make that work, ETC-250 racks were fitted under the fuselage, capable of carrying two 250-kilogram bombs. All that extra weight naturally called for more powerful engines, and the aircraft got the new DB601N units. Higher compression, reworked cylinder heads, and special high-octane fuel pushed takeoff power up to 1,200 horsepower. And in an emergency combat situation above 16,400 feet, those engines could push out 1,270 horsepower for up to 1 minute. That strike variant with the new engines and bomb racks was designated the Bf-110C4B. To figure out the best way to use a fighter bomber like this in actual combat conditions, the aircraft were sent to a dedicated test group whose job was to develop effective tactics. In July 1940, these fighters, flying alongside Bf-109E escorts, began hunting shipping in the English Channel and managed to do real damage to British traffic there. Later, during the Battle of Britain, German pilots flew these fighter bombers either alone or in very small groups, relying on surprise more than anything else. At the same time as the strike version, engineers developed a dedicated reconnaissance aircraft, the Bf-110C5. The heavy cannon were removed and replaced with a powerful RB-5030 aerial camera. In early summer 1940, these reconnaissance variants began joining squadrons, initially flying alongside DO-17P and DO-17Z bombers. Interestingly, the first twin-engine fighter of this type to fall into British hands was one of these unarmed reconnaissance versions. In July 1940, it made a forced landing on English soil near Goodwood. The damage was minor, and British mechanics repaired it by simply pulling parts off another downed Messerschmitt nearby. By autumn, British pilots had the restored trophy back in the air for their own evaluation. The standard reconnaissance variant ran on DB601A1 engines, while a slightly improved version got the same high-output DB601N motors. Right from the start of the Norwegian campaign, one serious problem became obvious. The standard fighters simply did not have the range. Command needed continuous air cover for important coastal convoys running along the Norwegian shoreline, so engineers had to come up with a solution quickly. The answer was a long-range version fitted with a massive, 1,200-liter auxiliary fuel tank. The tank was built from ordinary plywood and bolted directly under the fuselage belly. Its distinctive, elongated shape earned it a nickname from the pilots, the Dachshund belly. But there was nothing funny about flying with it. With the tank full, the aircraft became heavy and sluggish to handle. Even once the fuel ran out, the enormous tank created serious aerodynamic drag. In theory, the plywood pod could be jettisoned once the engines had burned through the fuel, or dropped in an emergency if an enemy attack forced the issue. This long-range variant received the official designation Bf-110D. A handful of standard aircraft were first fitted with the plywood Dachshund belly purely for military trials under the designation Bf-110D0. Full-scale production of the Bf-110D1R1 followed soon after, assembled on the same lines as earlier variants. The heavy fighter wings were first to receive them, immediately putting them to use on long patrol runs between the Norwegian cities of Trondheim and Narvik. But the combat record of this variant turned out to be pretty grim. For reasons command could not explain at first, these aircraft began suffering catastrophic losses on long-range missions. In cold temperatures, the massive under-fuselage fuel tank, still called the Dachshund belly, had a particularly nasty characteristic. Once the fuel was gone, the tank would warp and partially collapse, and the release mechanism was notoriously unreliable, frequently jamming. Engineers eventually discovered another deadly detail. poor venting left traces of fuel and explosive vapor sitting at the bottom of the empty tank. Any spark set off a powerful explosion, and that explained the mysterious losses during flight. To fix the problem, German engineers went back to the drawing board on an updated version of the Bf-110. Instead of one unreliable centerline tank, 2 wing-mounted drop tanks of 900-liter tanks were chosen. But before these new long-range fighters reached frontline units in any numbers, the Luftwaffe was already deep into the Battle of Britain. Some of the aircraft were moved to airfields in France. Despite the already well-known problems with the old tanks, on August 15, 1940, 21 Bf-110 fighters lifted off from Aalborg Airfield in Denmark. Their job was to escort He-111 bombers flying out of the Norwegian city of Stavanger. Their one clear objective was to destroy British military airfields near Dischforth and Linton on Ouse. German command had put together what they thought was a clever plan. They were counting on simultaneous heavy attacks in southern Britain, forcing the RAF to throw all its reserves south. That would stretch British defenses thin enough that the flanking blow from the northeast would meet little serious resistance. In practice, the attackers got a very unpleasant surprise. Spitfires from No. 72 Squadron spotted and intercepted them over the sea, well before they ever reached the English coast. The first casualty of that fight was the German unit commander, Captain Restemeyer. At the critical moment, he couldn't jettison his stuck Dachshund belly, and the first British round that punched through the tank turned the aircraft into a fireball. The other Bf-110 pilots ran into the same nightmare. Unable to drop their tanks, they lost their maneuverability and became easy prey for the interceptors. The German crews had no choice but to form a tight defensive circle. Meanwhile, the He-111 bomber formation had completely fallen apart. Some crews panicked and dumped their bombs into the sea, then turned back for Norway. Those who pressed on reached the English coast in scattered groups, only to find Spitfires and Hurricanes from other squadrons waiting for them. A handful of surviving He-111s tried to push through to secondary targets, but under constant fire they ended up dropping their bombs wherever they could. The Bf-110 fighters were already pulling back by that point. 7 of them were shot down, and several more barely made it home with critical damage. That was the only large-scale air raid launched from Norway, and with it, the 5th Air Fleet's active role in the Battle of Britain was effectively over. To put the scale of those operations in context, the numbers speak for themselves. As of July 20, 1940, 3 German air fleets had 278 Bf-110s on hand, including a small number of fighter-bomber and reconnaissance variants. Of that total, only around 200 were actually ready to fly combat. Nearly the entire available force of these long-range fighters was committed to the major offensive operation called Adler-Angriff, Eagle Attack. 3 weeks of intensive fighting later, the overall number had barely changed. The Germans had 289 Bf-110s, with 224 of them operational. For Adler-Angriff, German command had pulled in virtually every available staff and combat wing of long-range interceptors, throwing their best into British skies. The original concept called for the Bf-110s to use their endurance to drag British fighters into exhausting battles well before the main bomber force arrived. The logic was simple. By the time the main attack arrived, the RAF would already be low on fuel and ammunition. On top of that, enemy fighters heading back to their bases to refuel would be at their most vulnerable, turning them into perfect targets on the ground for German bombers and their escorts. But reality hit the German pilots hard. The Bf-110 simply wasn't built to play that kind of air superiority role. The twin-engine fighter had genuinely devastating firepower for offensive attack, but it was critically short on maneuverability. The single rifle caliber MG-15 guarding the tail against nimble British Spitfires and Hurricanes was nowhere near enough in a turning fight. On top of that, the aircraft's acceleration and top speed gave it no realistic chance of breaking away from a numerically superior opponent. The consequences of that overconfidence were devastating. In August alone, 120 Bf-110s were destroyed. Inside 3 weeks of Adler-Angriff, the Luftwaffe had lost a full 40% of its elite crews. It was painfully obvious that offensive air combat was the wrong arena for the Bf-110. The Germans were still forced to keep sending them in, though, because the single-engine Bf-109 just didn't have the legs for those missions. Even after command sharply cut the sortie rate and tried shifting tactics, another 83 Bf-110s were lost by the end of September. The casualties were so severe that several wings had to be disbanded entirely. In the final weeks of the Battle of Britain, the type was used mainly in the reconnaissance and light fighter bomber roles. The whole episode was an embarrassment for Hermann Göring, who had publicly presented these crews as his personal elite. But it was too soon to write off the Bf-110. For all its failures in the summer air battles of 1940 over Britain, the real story of the aircraft was just getting started. When November 1940 came and harsh winter weather shut down large-scale raids, the Battle of Britain was finally over. But that same moment opened up a completely different future for the Bf-110, this time as a night fighter. And in that new role, it did far better. The seeds of that shift had actually been planted back in May 1940, when nearly 100 British bombers hit industrial centers and transportation hubs in Germany's Ruhr region in a massed night attack. The damage to the ground was serious enough, and Göring's personal reputation took a hit along with it. To fix the problem quickly, some Bf-110 crews were sent to Dusseldorf, where they began intensive training in night interception tactics. By summer, a group of pilots previously flying Bf-109s had transferred to the Bf-110. Together they formed the first proper night fighter wing. Their base was set up in the Netherlands, and they became the foundation of a new night aviation division under Colonel Joseph Kamhuber. Fittingly, the night before this unit was officially activated, the Germans scored their first kill in the dark. A Bf-110 flown by Werner Streib, the man who would go on to become the Luftwaffe's top-scoring night ace with 66 kills, intercepted and destroyed a British bomber. Over the following weeks, a few more kills were added to the tally. At that stage, night fighting tactics were still extremely crude. The pilot's own eyes were essentially the only tool available for finding the enemy in the dark. All the specialized equipment for night flying amounted to nothing more than exhaust flame dampeners on the engines and special glare shields to keep the crew from being blinded by their own gunfire. But the technology was moving fast. By September, the units were reorganized. Some crews transferred to twin-engine Ju-88 bombers converted into fighters, while the rest received updated Bf-110s. The key new addition was the Spanner Anlage system, a primitive heat detector that could pick up the heat signature from enemy aircraft engines in total darkness. The sensor was mounted right in the nose of the aircraft. It responded instantly to the hot exhaust gases of an enemy aircraft flying directly ahead, and the target showed up on a small screen right in the cockpit. The equipment worked reasonably well, but it had one major limitation. It only functioned at very short range. That's exactly why the newly appointed general of night fighter aviation, Joseph Kamhuber, was placing far bigger hopes on a different approach. He was banking on close coordination between his aircraft and an extensive searchlight belt that engineers had constructed back in late 1939. The system formed a solid wall of light to the west of the German city of Münster, positioned right across the standard route British bombers used. When British pilots tried to go around this light trap from the south or north, the Germans had to keep extending the searchlight line to match. Eventually, the entire industrial Ruhr district ended up divided into distinct sectors with its own group of night interceptors hunting inside each one. Given the tactics British aviation was using at the time, even a modest number of night fighters could inflict serious losses. The situation improved further for the Germans when they rolled out a full chain of ground control systems called Himmelbett, working in tandem with powerful Würzburg ground radars. The twin-engine Bf-110 remained the primary strike force of German night aviation through this period. By late 1941, though, it was absolutely clear that the available strength was nowhere near enough to properly defend the skies. General Joseph Kamhuber had been warning about this problem consistently, and events proved him right. To patch the gaps in the defense, German command began urgently forming new night fighter wings. Meanwhile, some questionable decisions were being made at the top. With the newer Me-210 expected to arrive soon, the Air Ministry under Erhard Milch decided to sharply cut Bf-110 production. To put that in perspective, in 1940, the factories had been steadily turning out over 100 aircraft per month, delivering more than 1,200 in total. The following year, the situation changed completely. Bf-110 production, at the main Messerschmitt and Focke-Wulf plants was shut down entirely. Fewer than 800 aircraft were assembled during 1941, and even those came mostly from outside contractors. Of the aircraft that were built, some were converted into reconnaissance platforms, while the rest served as heavy fighters flying sweep missions, fighter bombers, and night interceptors. The aircraft's development kept going, and the final representatives of the early C-series were highly specialized variants. One version that saw active service during the Battle of Britain swapped out the two standard 20mm MGFF cannon for a single, more powerful 30mm Mk-101. Another became a straightforward fighter bomber fitted with DB601N engines, reinforced landing gear struts, and heavy under-fuselage weapon racks. Neither of these variants went into large-scale production. The C-series era was coming to an end. Some older airframes were taken off combat duties entirely and converted into basic glider tugs. The D-series long-range fighters took over from there. One of its baseline variants, at maximum load, could carry two 1,100-pound bombs and two 300-liter drop tanks simultaneously. At the same time, engineers developed a dedicated version for maritime convoy escort. To keep the aircraft airborne for hours over open ocean, external tanks of 80 or even 900 liters were hung under the wings, with an additional oil tank fitted to the underside. The slightly lengthened tail also hid an inflatable life raft for emergency water landings, and the aircraft still kept its ability to carry heavy bombs under the fuselage. Starting in spring 1941, these newer long-range D-series aircraft began steadily replacing older models in frontline wings. They flew throughout the entire Balkan campaign and later saw plenty of action in the skies over the Mediterranean and North Africa. There was even one unusual episode in the Middle East. In May 1941, several Bf-110s were briefly deployed to the Middle East to provide air support for Iraqi insurgents, and Iraqi national markings were painted on the wings for the occasion. For the invasion of the Soviet Union under Operation Barbarossa, however, the type was committed in relatively small numbers. The aircraft that did go to the Eastern Front served mainly with fast bomber wings and dedicated strike groups. Even as Bf-110 production gradually wound down, late spring and early summer of 1941 brought two new variants of the heavy fighter bomber. Beyond updated equipment, a stronger airframe, and better protection, the new version added underwing weapon racks. That engineering decision pushed the maximum bomb load up to 2,645 pounds. When bombs weren't needed for a mission, 300-liter drop tanks could be hung in their place and jettisoned once empty. Early production batches still flew on the proven DB601A engines, but later aircraft were progressively upgraded to the more powerful DB601N. Engineers developed several specialized versions: a night fighter equipped with a heat detector for finding targets in total darkness, a version with a third crew member acting as a third crew member to coordinate the intercept, and a pure strike variant capable of carrying two enormous 1,000-kilogram bombs under the fuselage. By 1942, updated fighter bomber and long-range reconnaissance variants had entered mass production. The bomber version notably had a life raft built into the tail section for the crew in case of a ditching. The reconnaissance variant, meanwhile, gave up some of its cannon and bomb racks in exchange for a powerful camera mounted directly on the cockpit floor. For truly long-range work, it could carry either two 300-liter drop tanks or one large 900-liter tank. This variant also introduced the first attempt at defending the rear. Two MG-17 machine guns in rifle caliber were mounted on either side of the fuselage, firing straight back along the fuselage. The next variant in the family was built in parallel and showed no dramatic external differences. Its main advantage was the new DB601F engines, which delivered a solid 1,350 horsepower on takeoff. The problem was that the combat weight of the aircraft had been climbing steadily as new armor and weapons were added, while engine power had stayed the same for too long. That had gradually eaten into the Bf-110's speed, maneuverability, and overall handling. The arrival of a significantly more powerful engine finally gave the aircraft back the flight characteristics it had been slowly losing. While most new airframes rolled out as fighter bombers and reconnaissance types, designers had planned dedicated variants for fighter sweep operations and night interception right from the start. The first prototypes of this series differed from their predecessors mainly in the new engines and enlarged oil coolers, which kept the power plants from overheating during hard fighting. Once the aircraft entered full production, however, it received serious crew protection. A 57mm armored windscreen became standard equipment. That turned out to be such a good idea that it was retrofitted to older variants too. The side cockpit windows were protected by 35mm armored glass. A solid steel armor plate 12mm thick went in directly in front of the pilot, and 8mm armor covered his back. The rear gunner got similar treatment. The same steel plate behind his position and 2.24-inch armored glass above his head. The aircraft's weapons load was equally impressive. Under the fuselage, it could carry heavy, high-explosive or fragmentation bombs of 551 pounds each, or large 500-kilogram bombs. It could also carry cluster bomb containers that opened automatically at a preset altitude, scattering dozens of smaller submunitions across a wide area. Under the wings went lighter ordnance, 110-pound bombs, or cluster containers, each holding 24 small 2-kilogram bomblets that scattered the moment the container was released, laying down a dense and lethal pattern across the ground. Among all the variants was a pure fighter with no bomb racks and a dedicated reconnaissance platform. The Reconnaissance version ended up being the one built in the largest numbers. In autumn 1941, though, German command, specifically on a direct order from Erhard Milch, halted Bf-110 production at several key plants. The plan was for the newer Me-210 to step in quickly as a replacement. That turned out to be a serious miscalculation. The new aircraft had a long list of handling problems, and fixing them properly was going to take months of valuable time. The unexpected failure forced German leadership to restart Bf-110 production in a hurry, and by February 1942, the factories were back at full capacity, pushing the proven combat aircraft to the front. Meanwhile, Messerschmitt's engineers kept working to squeeze as much capability as possible out of the design. By this point, the United States had officially entered the war, and the British night bombing campaign was growing steadily heavier. To adapt, several new armament options were developed for the Bf-109F2. Almost simultaneously, the Bf-110F2 was built specifically for night fighter wings. During trials at the Tarnowitz range, the aircraft was tested with the new WFR-GR-21 rocket projectiles. From 1943 onward, those rockets were actively used on so-called formation breakers, aircraft whose job was to blast apart tight bomber formations. The installation was straightforward, 2 launch tubes under each wing. One experimental prototype also tested RZ-65 rockets, intended primarily for ground attack. A full battery of 12 launch tubes was mounted under the fuselage. That prototype arrived for live fire testing on October 5, 1942. Engineers even considered adding 3 more launchers on each side of the cockpit, but the test results were so discouraging that the whole ambitious project was scrapped entirely. The next night, fighter variant, the Bf-110F4, got a serious boost in firepower. A pair of Mk-108 cannon in 30mm caliber tucked inside a ventral fairing under the fuselage. To make single-engine handling more manageable if one power plant failed, the tail fins were repositioned and the rudder area was significantly increased. The crew expanded to 3, and carrying 300-liter drop tanks became completely standard practice. In summer 1943, German engineers took a different approach on some aircraft. The lower-mounted Mk-108 cannon were moved into a system known as Schräge Musik, which translates from German as jazz music, or literally oblique music. The rear defensive MG-15 was removed entirely. The installation looked unusual. The cannon were fixed to a bulkhead directly behind the crew. Their barrels punched up through the cockpit roof and pointed upward at 15 degrees from vertical. The pilot fired the system using a specially angled Reeve gun sight mounted on the windscreen. Starting in summer 1942, Bf-110 F4 fighters began receiving FUG-202 Lichtenstein airborne radar sets in large numbers. The combat evaluation of this equipment, run under the code name Operation Adler, was conducted at a base near the city of Venlo and was a complete success. After that, radar sets were fitted to night fighters as fast as Telefunken could manufacture them. The armament lineup was updated. The 4 forward-firing MG-17s and 1 rearward MG-15 stayed in place, but the older MG-FF cannon were replaced by more capable MG-151s of the same caliber. Ammunition storage, as before, was kept inside the cockpit. 300 rounds for the left cannon and 350 for the right. 2 300-liter drop tanks were standard. The most recognizable feature of this model was the set of 4 radar antenna arrays on the nose, which the crews nicknamed the mattress. There was a price to pay for all of it, though. Normal takeoff weight climbed to 20,500 pounds. Combined with the drag of those bulky antennas, that took a serious toll on performance. Maximum speed at 18,370 feet dropped to barely 315 miles per hour, and maximum range shrank to 518 miles. Series production of these radar-equipped fighters ran without interruption through all of 1943. It finally stopped when the MIAG and Gotha assembly lines fully transitioned to building the next-generation G-series aircraft, powered by the new DB605 engines.